We're now going to go through some back titration calculations. We'll do three worked examples together. The questions will come up. As you get more confident, perhaps you could have a go at them before looking at the answers. Completely up to you and how confident you feel. This is a really difficult topic. So first things first, let's go for question number one. So we have an impure sample of calcium hydroxide and we're reacting out of an excess of hydrochloric acid. Any acid left over we are going to titrate against using 0.500 moles per decimeter cubed sodium hydroxide, and we find the titer is 10.9 centimeters cubed. And we need to calculate the percentage purity. So first thing we need to do is look at the information we've been given, and we can immediately work out how many moles of HCl did we start with by timesing the concentration by the volume, remembering to convert the volume into decimeters cubed by divided by 1000. So we can find our moles of NaOH by multiplying the concentration by the volume of the titer, remembering to convert that into decimeters cubed by divided by 1000, and we find we have 0.00545 moles of sodium hydroxide. By looking at the equation that happened during the titration, we can see it's a one-to-one reaction between HCl and sodium hydroxide. So I have the same number of moles of HCl as sodium hydroxide, and therefore I can find the moles of HCl that reacted by taking the first figure, which was the number of moles that we added, and minusing the second figure, which was the number of moles of HCl that were left over. So we can find out we had 0.0133 moles of HCl that reacted with the calcium hydroxide. Let's have a look at that equation, and we can see for every 2 moles of HCl we just need 1 mole of calcium hydroxide. So moles of calcium hydroxide is going to be 0.0133 divided by 2, and then it's quite a simple process to find the mass by multiplying by the molar mass of calcium hydroxide to give me 0.4928 grams. And finally, percentage purity is going to be 50.4%, and that's just going to be how much calcium hydroxide I had divided by the total mass of the sample times 100. So let's do worked example number 2. We take 5.20 grams of a sample that contains ammonium chloride. We add it to 75 centimeters cubed of 0.75 moles per decimeter cubed sodium hydroxide and heat it until the reaction has finished. We take 25 centimeters cubed of that solution, add it to a conical flask and titrate it against 0.500 moles per decimeter cubed sulfuric acid, and we then have our 2 consistent titers there. So let's find out how many moles of sodium hydroxide we added at the beginning, which is concentration times the volume, with the volume in decimeters cubed. We can then find out how many moles of HCl did we use in the titration, which is again concentration times the average titer, which will be 22.55 divided by 1000. And then by looking at the equation, we can find the number of moles of sodium hydroxide in the 25 centimeters cubed that we extracted to do the titration with was 0.011275 moles. Remember, of course, that originally we had a solution of 75 centimeters cubed. Therefore, we need to scale that up to 75 centimeters cubed by dividing by 25 and timesing by 75. So we now know the original moles of sodium hydroxide added, and we know the moles of sodium hydroxide that remained. So the moles of sodium hydroxide reacted is going to be 0.022425 moles. We have a look at the equation, and 2 moles of sodium hydroxide reacts with 1 of ammonium sulfate. So we divide that number by 2 to find the moles of ammonium sulfate, and finally we find the mass of ammonium sulfate that reacted by timesing by the molar mass to give us 1.48 grams. Final worked example then. We now have a sample that contains copper and zinc powders in a beaker, and we add 150 centimeters cubed of 0.1 moles per decimeter cubed sulfuric acid. Zinc reacts. We then filter that solution into a volumetric flask. Make sure that we've washed the beaker and filter paper thoroughly with distilled water so that everything is transferred to the volumetric flask, and make it up to 250 centimeters cubed. We can then extract 25 centimeters cubed of that solution using a pipette and titrate with sodium hydroxide, and we find the final titer to be 15.25 centimeters cubed, and we need to find out how much zinc was in that sample. So, start as we normally do. How many moles of sulfuric acid did we start with, which is concentration times volume over 1,000. We can then find out how many moles of sodium hydroxide would we use in the titration, which is just going to be the same of concentration, which is now 0.1 times 0.00725. And look at the equation for that titration, and we can work out our moles of sulfuric acid is going to be the moles of sodium hydroxide divided by 2. Remember, that was in 25 centimeters cubed in the conical flask that we extracted, but originally that was in 250 centimeters cubed, so we times by 10 to give us 0.003625 moles of sulfuric acid that remained. So the moles that reacted is the moles we started with minus the moles that were still present, to give us 0.071375 moles. Let's look at the equation, and it's a 1-to-1 reaction, so that's the same number of moles of zinc that are produced, and so the mass of zinc is going to be moles times molar mass, and that gives us 4.67 grams of zinc were present. So hopefully you found those 3 worked examples useful. As I say, our back titrations are tricky. They do like giving them to you to do in the exam because they are rather challenging.